My name is Camden Ford. I'm going to be presenting today, talking a little bit about how to use virtual I/O in resource management and resource provisioning in the cloud. So basically what I'm going to run through today is up here on the board. We're going to run through kind of taking a look at what kind of cloud services you can provide. Today when you look at cloud services, it's primarily renting a VM. Storage means capacity, no tiers, no reliability. Networking means connectivity, no bandwidth guarantees, no latency guarantees. So we're going to talk a little bit about that just to kind of level set. And then when you look at it, what resources do you actually have to manage when you're deploying a cloud? Let's talk about the cloud services, right? So like I said, typically when you look at a cloud service, something like EC2 or Rackspace Public Cloud, what you're really renting is a VM. You get CPU, you get memory. You don't really get a lot of options on what you get as far as type of storage, type of network, guaranteed bandwidth, guaranteed services, guaranteed reliability, guaranteed availability. You need to start looking about that, right? Because public cloud is one thing. Nobody's making any money there. But if you're doing a private cloud, you really need to look at what kind of services. How are you going to differentiate your services both internally and to external customers? How are you going to tier those services? How are you going to add value in that infrastructure? Then you have to look at your service level agreements. What are you going to offer? Today it's kind of uptime, and if it goes down, so what, it doesn't cost much, right? Because that's the public cloud. In the private cloud, if you want to convince people to put their enterprise apps in your hands, whether it's your own company or some other company, you're going to have to be serious about uptime guarantees. You're going to have to look at provisioning guarantees. How long to spin up a VM? You're going to have to look at security guarantees. What if I need isolated networks? What if I need guaranteed bandwidth? You're going to have to look at recovery guarantees. How long to recover if there is a failure? You're going to have to look at performance guarantees. How do I get the bandwidth I need? How do I guarantee my apps are going to perform properly? When you look at that, what kind of resources will you have to manage in order to deliver these kinds of services and SLAs to your customers? Well, the easy one is on the server side. You're going to have to manage processing power, CPU cores, MIPS, whatever that turns out to be. Memory, how much memory is available, what type of memory. Storage, LUNs, file space, file namespace. Networking, it's things like client access, security, server-to-server connectivity, connectivity to back-end services. So at the end of the day, the real goal in delivering services are how do I map resources to create a service? Ultimately, a service is compute plus networking plus storage. That's not a big stretch here. But part of what we're here to talk about is, look, keep it simple. You've got certain skill sets in your environment. You've got certain tools available today. Pool your compute resources. Pool your network resources. Pool your storage resources. Do it by type. That way you can scale your pools independently. You can optimize based on the functional skill sets that you have in your environment. It's not a really big epiphany there, right? On the host side, right, when you're looking at scaling your CPU and cores, you're looking at things like vCloud, different tools like that to provision, orchestrator. And what you're really provisioning are MIPS and megaflops to an application, which ultimately turns into CPU cores, clock speed of those cores, memory capacity, memory type, and clock speed of that memory to be able to guarantee a level of service. Today, again, in the public cloud, you don't get to pick a clock speed. You don't get to pick a memory type, right? You don't get to specify a performance level that an application must execute at. Coming in a private cloud, you better start thinking about that because people we're talking to are thinking about it. So the big key is when you start looking at the networking resources and the storage resources, what is a network resource? Basically, networking resources are connectivity for a specific purpose. Secure connectivity to external client networks, secure connectivity to things like load balancer appliances for scaling your apps, secure connectivity to WAN connectivity for replication, redundancy, access to other facilities, secure connectivity to back-end services, things like backup, performance management, health monitoring, etc. Secure connectivity between compute resources for different application performance within the cloud itself. But how do you characterize that? When I go out and buy a networking resource, what am I paying? What am I paying for? How do you characterize that resource? Ultimately, you have to look at security level, right? Is this a VLAN? Is it isolated? Is it a dedicated port? Is it physically segregated? Is it shared? How do I provide that security level? How much bandwidth am I going to guarantee? Do I need guaranteed bandwidth? Am I willing to pay for it? What about latency? Do I have latency-sensitive applications? Do I guarantee that I'm only going to switch one hop across the infrastructure? Or is somebody going to shuffle a VM somewhere where I got to go 5 or 6 hops across various networks to be able to talk to my other applications? What about time to provisioning? If I need to spin up more capacity in the infrastructure, how long do I have to wait? Do I have to do it 2 days ahead of time, a week ahead of time, or 10 minutes ahead of time? Scalability. What if I need to scale my app out? How far can I scale within my SLA? right? And there's all kinds of parameters like that. When you start thinking about the resources that you're going to manage on the networking side, you need to start thinking about how you characterize those resources so that you can tier those services and charge people for those. This is just a quick diagram I pulled off the web just to kind of show what network resources are. If you look at a big enterprise network diagram, you've got firewalls going out to the internet, intranet, extranet, your security domain management, your DMZ, your corporate portal. These are the network resources that the infrastructure guys are managing, right? In these resources, there's no SLAs here, there's no guaranteed bandwidth. This is just a general infrastructure. If you're going to offer these types of services within a cloud environment, you need to start thinking about how you're going to characterize each of these resources and guarantee service levels around them. So one of the things we're here to talk about is that the traditional model of building out that infrastructure that we talked about is to build a giant network where everybody's connected to everybody so that any resource can talk to any other resource. Well, we're here to tell you with Virtual I/O you have another option. And that option is to start breaking down those big networks into much smaller manageable chunks. You can segment by function, minimize your complexity, provide service isolation so that this service doesn't impact that service. You can guarantee bandwidth. You can tier your services by segregating the functionality. You can scale these much, much easier. And talk about debug. If I had to debug that big, large cloud environment, right? I mean, what a nightmare when I got thousands of VLANs running around on the same infrastructure and I get a packet storm in there. I think that happened over here in the Moscone data center last night, but that's a different story. But it gets a real pain to debug when you get these large infrastructures scaled out in a single network environment. So part of this is that with Virtual I/O, you can now start breaking those down by functionality. I can have experts on the core network, experts that know how to deal with intranet, extranet, firewalls, load balancers, different types of services, build, maintain, and manage their discrete environments. And you can cable it any way you want. You can have them as separate networks with small switches that are very low cost. You can have it all tiered off and split off of your core. I don't really care how you build it, but the concept here is break it down into small chunks. Because with Virtual I/O, we have a way that you can provide all of these resources mapped back to your servers and your service platforms without having to have them belong to a giant consolidated network. So storage resources, let's talk about this for a second. At the end of the day, what is a storage resource? Well, it's pretty easy on storage. It's capacity for files, block storage, table space, things like that. Storage is really interesting because there's a lot of things that you can do in storage to characterize a system and offer tiered services. Internally, big enterprise IT shops already do this. As part of a cloud, they don't. As part of a cloud, they're throwing it all on a filer somewhere, or they're throwing it in some big-ass distributed storage system. Ultimately, you can actually very well characterize your storage subsystem, and you can offer that as a service to your business or to your customers, right? You can look at security level, dedicated LUNs, dedicated ports, dedicated heads. You can look at throughput. Do I have dedicated ports, fractional ports, shared ports, best effort ports? Head performance, how do I optimize that? Do I need to use SSDs, 15K drives, 10K drives, 7200 RPM drives? What kind of stripe configuration? What kind of read performance, write performance am I going to deal with? You can go out there and characterize your environment, define that environment, and you can offer that as a very specific service level within your service. Again, IOPS services, the same thing. You can go load up SSDs, 15K drives, 10K drives, different stripe configurations optimized for different types of applications, and you can offer that as a generic tiered service within your infrastructure. The big question is, do you know what you paid for, and did you get what you paid for? So on the storage side, it's the same message. Ultimately, what we want you to do is forget about building a gigantic SAN that does everything, because it doesn't, and it's a nightmare. If you have a problem in that big SAN, it's going to take the whole thing down. It's a huge disaster. So break it down. A lot of people already do this in the storage environment because they have segmentation by protocol. I got NFS, runs on one network. I got iSCSI, runs on another network. I got Fiber Channel, that runs on another network. I got backup that runs on a separate network. We're saying, hey, do that even more, right? Take it out where you can have your fiber channel experts manage your SAN or multiple SANs. I can have different types of SANs with different types of arrays and different configurations, and I can charge different prices for that internally and externally. I can run different types of iSCSI connectivity, 1 gig, 10 gig, different stripe configs, distributed, and I can charge different ones for that. I can do different types of filer head configurations, distributed, parallel NFS, things like that I can break out into different functions, and I can actually segregate by function. I can have dedicated teams or people with expertise to manage those environments. I can scale them independently. I can guarantee bandwidth downstream. I can provide service isolation. I can tier my services and charge different prices for those. I can scale it much easier because it's much smaller chunks. And by the way, this costs a lot less because I can do much smaller SAN switches, much smaller network switches, and I don't have to worry about management of this gigantic infrastructure, and much, much easier to debug when you have problems. The other part is when I have a problem in one area, it doesn't affect the other areas. So this is what we do. With virtual I/O, ultimately we can provide different virtual connections to different virtual networks, different physical networks, different downstream ports, different configurations, and present those back to any of the compute resources as required, fully dynamically, without having to converge all of your networks. So what is virtual I/O? Basically, this is what Seego does. Virtual I/O is actually the opposite of converged I/O. When you talk about converged I/O, we're most likely talking about things like CNAs and FCOE, where I take every protocol I can think of today and I jam it into one adapter and I put that adapter in the server. But when something else comes out next week, next month, next year, I got new feature sets, new capabilities. If I want that old server to have that new feature set, I got to go crack it open. I got to plug a new CNA in there. I got to plug in a new 40 gig one. I got to plug in new features. I got to add more addressing, different types of capabilities. With Seego, what we do is we actually do the opposite of that. We pull all of the I/O protocol out of the server and we aggregate it down into our Seego I/O director. So now the I/O director down here in the center, it houses all of the NICs, all of the MAC addresses, all of the worldwide names, all of the HBAs, all of the protocol intelligence and functionality lives outside the server. This is very similar in approach to what some of the PCI Express guys are doing, but PCI Express is not a network technology that you can scale out and manage and provide the types of services that you need in a cloud infrastructure. So ultimately, we use different technologies. Ultimately, we have a connection back into that server because we have to. And what we use is RDMA. We use a reliable transport, whatever's cheapest and fastest. We have 3 different options today in our products. We have a 10 gigabit CEE fabric that can run on top of a standard 1 gig or 10 gig Ethernet. We have a 20 gig InfiniBand option, which we've been selling for about 2 years now. We have a 40 gigabit InfiniBand option that we can connect back in and run at very high speeds for larger servers. So the end of the day, we're using that pipe just for a fat, reliable transport. So the solution is exactly the same, whether it's 10 gig, 20 gig, or 40 gig, Ethernet or InfiniBand. If some other new protocol comes down the pipe that's faster, cheaper, and reliable, we can plug in a module there and that all works. With our solution, you put a set of drivers from Seego on top of that server, and these are thin drivers that basically extend the I/O bus out of that server back into our box where we house our NICs and HBAs. As an example, we actually use QLogic HBA chips on our I/O module. Behind that QLogic chip, we have our virtualization ASIC that turns that single fiber channel adapter into 128 virtual adapters that we can apply to any of these servers in any combination. So we can take one QLogic fiber channel adapter and share it across 128 servers. We've got a new 2-port 8 gig fiber channel card coming out that we can share with 256 servers. So we can plug in a new technology when it comes down the pipe, and we can present that interface all the way back to that server. Now, because the I/O lives outside of the box and all the MAC address and worldwide names live in our box, not in that server, we can very easily move those NICs and HBAs around. So you wire it once, then you can go provision NICs, HBAs, connect those to any of your downstream networks. Well, let's say you need to add a new network in, and I need to add a new NIC to these servers. I need to go to add a new interface to access that new network. In the I/O director, we plug in new I/O modules. We hot plug them. Once they're plugged into the system, you can create new NICs and new HBAs on any server in the fabric to access those new cards. So basically, it's fully non-disruptive. You haven't rebooted any servers. You haven't touched any cabling. We had to add some new cabling when we added new I/O cards. So it's a fully dynamic environment that allows you to have any I/O presented to any server at any time and shared completely across the environment. Another big benefit of this approach is that I/O does live outside the server. We now have the ability to add in any new protocol that we want into that box, and now you can present that back to the server. So today we're shipping our 10-port 1 gig E card, our 10 gig E card, our 2x4 fiber channel card, and we're about to ship our 2x8 fiber channel card. We're actively working on a 2x10 gig FCOE card, an iSCSI HBA card. We're working on our 2x10 gig E card with some load balancing capabilities. Behind that, we're starting to line up an 8-port SAS SATA RAID chip. So we can hang JBODs off the back of our box. We can hang SSDs off of our box. And then eventually we'll plug in 40 gig E when the cost comes down and the power gets down to where it's deployable. So we can add in any protocol, any networking technology into this box, and you can instantly upgrade and add connectivity back into any of those servers without changing any of your cabling. More importantly, you can present multiple interfaces simultaneously to that server. Let's say I want to upgrade from 4 gig fiber channel to 8 gig fiber channel. I plug that new card in. I can present new virtual HBAs that terminate on that 8 gig fiber channel card right alongside my 4 gig fiber channel virtual HBAs on the same server at the same time without rebooting anything. I can set my app up for synchronous mirroring. I mirror my LUNs over to the other side, and then I can remove those 4 gig HBAs and pop that card out if I want to free up that slot. Or I can just leave them in there and let them run all day long. This is what our box looks like. We've got two flavors. We've got our 4U chassis, the 780, and our 2U chassis, the 560. The only difference is that we have 15 slots of I/O uplink capability in one. We've got 4 slots in the other. The internals are the same. What we're showing here in the current product is our 20 gigabit. We have 24 ports of 20 gigabit InfiniBand. We do have a new 10 gigabit 32 port CEE blade that we're showing in the show floor. We can plug that into existing 10 gigabit, 1 gigabit NICs. It all works perfectly fine. No CNA is needed. We can present fiber channel, Ethernet, iSCSI, whatever you want back into those servers. You never need to buy a CNA with that solution. If you need higher performance, we do have our 20 gigabit platform, which, by the way, is lower power and higher performance and lower cost than 10 gig E today. And we have our new 40 gigabit platform that we're showing on the floor and we'll be shipping in a couple of months. One of the other advantages of virtual I/O, because the I/O lives outside of the server, we now have a completely different scaling mechanism. So if you look at a traditional deployment, this is pretty much what we would look like. You might put this and call it a top-of-rack solution where we've got a couple of blade chassis cabled into our box. Because this architecture is 20 gig InfiniBand, I've actually got 4 links coming out of each blade chassis into my 2 directors in a redundant configuration. I've got 4-to-1 over subscription. I've got an average of 5 gigabits per blade in that infrastructure. If I need more I/O, I can add more I/O directors. I can have any server access any of those I/O directors or all of those I/O directors at the same time. I just changed my oversubscription to 10-to-1 by adding more I/O directors because I just added more I/O to the infrastructure. I can add more servers. I can add more I/O. I can add more servers, more I/O. And this scales to very large numbers. One of the other advantages of this approach is now I can scale my I/O independently. I can scale my servers independently. I can actually switch traffic across my I/O chassis between these servers. And because the switching occurs down here in the I/O director, on a point-to-point configuration, I can configure a server on the bottom left to talk to a server on the bottom right just by pointing a virtual NIC to a specific port on the chassis. I point both the virtual NICs from both the servers to the same physical network because I need them on the same network to switch, and traffic will pass across. So I can scale to very large server numbers, very large I/O numbers, and I can have any server talk to any other server in the back-end fabric on a dedicated bandwidth pipe connecting through our infrastructure, and I can scale that horizontally. So how do you provision this virtual I/O? Well, if you look at a traditional ESX host today, most everybody's 1 gig infrastructure. They're starting to look at 10 gig. They're starting to look at these other technologies. What you see is a whole bunch of NICs and HBAs, but not because they need 10 gig of bandwidth in the system. The reason there's 10 NICs in there is because you need to isolate that traffic. I've got a management network, a console network, a vMotion network. I got a customer production. I got backup. I got iSCSI. I segment those out by throwing NICs into that server so I can run those off to different ports downstream, and I can be assured that there's no data integrity problems. I can pass my PCI compliance, and also I can guarantee bandwidth for particular applications as I need them. With Seego, we can do exactly the same thing. We can isolate networks, segregate traffic, and dedicate bandwidth all the way back based on a virtual NIC architecture, just like your physical NIC architecture, but it does it over a single pipe, or 2 pipes for redundancy. We also have a new concept that we're demoing in our booth. It's obviously not a great marketing name. It's a cloud, but it's appropriate. A cloud is a set of resources that can be dynamically allocated. So we have 2 constructs that we've developed to help manage this infrastructure. We have a network cloud and we have a storage cloud. And the idea here is, just like we talked about segmenting your infrastructure, I can dedicate a group of Seego ports, And I can tie them off on a particular port on a downstream switch, and that's going to be my firewall network, my VPN, my load balancer, my management network, my production network. I can dedicate a port to that particular function, or I can share that port and put it on different VLANs, however I want to manage it, and I can designate that as a cloud. Same thing in the storage environment. I can have SAN A, SAN B, SAN C. I can have this group of LUNs, that group of LUNs. They can all be allocated to a storage cloud, just as a logical entity so that I know what resources I'm actually configuring and managing. The characteristics of these clouds are things like bandwidth. We've got total bandwidth, committed bandwidth, and available bandwidth. We've got connections, which in SIGO terms are virtual NICs and virtual HBAs. We've got quality of service. We've got VLAN and VLAN ranges. We've got LUNs and how those LUNs are presented. We've got permission and access control. So these are the high-level characteristics of the SIGO cloud. Now, you still have to configure your downstream networks and your downstream storage infrastructure to be able to map and characterize that service to be able to offer to somebody. But we're giving you a way that you can partition that infrastructure using virtual I/O, and you can define what that resource is for the server guys so they know what resources they can go attach to. So if we look at what you would do is your networking guys would come in and they're going to provide you a cable, just like they do in the server today. Here's my management cable. I'm going to plug it into my management port or a couple of ports. And I'm going to say, I'm going to use ports 1 and 2 on this box. I'm going to set up my QoS for 10 megabits because I don't want anybody going crazy on my network, on my management network. And I've got 320 connections available. I've got 2 gigabits of bandwidth, and I want to restrict my VLAN range down to VLANs 1 and 10 for my various management networks because I don't want to get a bunch of multicast traffic on my management network. Now I got a backup network I got to configure. Let's run a couple of 10 gig ports in there. I'm going to make them ports 5 and 7. I'm going to let them burst to 10 gig, and I've got 20 gig of total bandwidth, and I'm going to restrict those VLANs between 20 and 200 because I don't want people to get crazy and start allocating VLANs out of their ranges. I can configure a couple storage ports in the infrastructure. I'm going to use my SAN ports 10 and 11. No QoS this time. We've got 256 connections and 8 gig of total bandwidth. Once I've configured my clouds, now my server guys can come in and map resources into those clouds. So what I do is I create a template. And a template basically takes a connection, a virtual NIC or a virtual HBA, and it maps it over to a cloud. So a cloud is a resource that somebody needs to use. The server guys don't care what ports. They don't care whether it's 1 gig or 10 gig. They don't care whether it's SAN A, SAN B, or SAN C as long as they get their LUNs, right? So the server guys come in and say, I need a management connection, I need a backup, I need NFS, I need SAN, I need firewall, I need these different connections to make my applications work. I'm going to let somebody else worry about the rest of that stuff. Once I create a template, now I can go deploy that template onto servers. So with virtual I/O, we drop this template on 1 server, 10 servers, 100 servers, 1,000 servers. Under the covers, SIGO automatically configures the virtual NICs and virtual HBAs and maps those out to the downstream resources as they're defined by their cloud definitions. So ultimately what you end up with is a logical configuration where you're connected out to these different functions downstream. And these can be separate networks, these can be one network. You decide how you want to manage it, we don't care. But we do give you the ability to now isolate these network segments downstream so that you can control these resources better. But the beauty of this approach is it scales. So I can add in more servers, more I/O directors, but I haven't changed my template, I haven't changed my provisioning model. All I've done is added more ports into my clouds because I've added more firewalls, I've added more storage resources, I've scaled out my SAN, I've added more LUNs, and I've added more ports into my SIGO chassis, and I just add those ports back into my cloud, and my template now goes and maps the rest of that stuff. So I don't have to change my provisioning mechanism as I scale my environment out. I don't have to change how my infrastructure is managed, I don't have to change how it's segmented, and I don't have to change how I control my segmentation and my bandwidth downstream. We have one other benefit. This is a brand new feature we've added in. We do have the ability to now map I/O across multiple physical locations with multiple chassis from the SIGO environment. So traditionally, when you ship a box, it comes with a pool of MAC addresses and worldwide names. It has to be unique to that box so that you don't have overlap and duplicate MAC addresses and all those kinds of problems. We ship the same thing. We have a pool of 4,000 MAC addresses and 4,000 worldwide names in each SIGO chassis that are unique. Well, if I've got a SIGO chassis in an environment on one area, I got another one in the other area, and I want to map the I/O across, I can now drag that and drop it to the other side because our management application now sucks up all of those MAC addresses and worldwide names into a single pool, and now I can manage multiple locations, multiple virtual I/O infrastructures as a single unified environment. So we let you flatten out how you define your environment. And the way I do that is through my cloud definitions. So I can create a cloud that has ports on the chassis in one location and ports in the chassis in the other location because they're all under central management. When I move that I/O from one location to the other one, my template says all I need to do is map my virtual NICs to a cloud. If I've got the right cloud in the right location, it's automatically going to remap to the appropriate ports on the other side, and it's going to carry along all the VNIC characteristics, VLANs, QoS, MAC address, worldwide name, whatever it is that goes with that server I/O profile. So we can now move that around any way we want, and we can scale it across multiple environments, multiple locations. So this is just a quick look at the GUI that we use to do this. This is our management application. We call it XMS 3.0. We have a little dashboard that gives you a snapshot of the environment. We've got a nice GUI where you can go in there and look at how the I/O directors are mapped out. The physical outbound ports are mapped into their cloud definitions. We've got a template where you can go in there and add in your VNICs and VHBAs and easily drag and drop and map them over to your clouds. We've got a big topology view where you can look at your server groups. We can actually do functions by groups. So when you're managing a very large environment, you better find a way to organize and group your environment so that you can do functions in mass rather than doing it one at a time. So we have grouping, and you can apply cloud connections to groups, VNICs and HBAs to groups, and things like that. And then lastly, what Dave wrote over here is our new iPad app that does it all on the iPad. It's very, very cool. Stop by our booth, and you can see how it goes. But as an example of how people use this, we have Matt Calger from Salesforce.com. He's going to come up and chat a little bit about his environment and what he does with Seago. Click through that. Oh, it's on. You just got to. There you go.
There we go. All right. Oh, wow, that's long. So yeah, I work for Salesforce. Most of you have probably at least heard of us. It says far too many buttons.
Left one goes forward.
Okay, let's try this again. There we go. All right, we're going to skip right past that. So what do we need to build? Everybody that uses Salesforce runs the exact same version of Salesforce, right? We don't ship you a CD and you then install it and all that jazz. Everyone runs the same version of Salesforce, which is great for us and great for you because we really only have to support one version of Salesforce. The downside to that is that when we have a bug, everybody has the bug, right? So there is no bug that doesn't affect every single Salesforce customer. So we do an enormous amount of continuous integration testing. The short version of continuous integration testing is when a developer checks in a new version of the code, we test that new version of the code. We test it unbelievably intensely. Because we have only one application under test, what we really needed was a way to do that extensive testing in a grid, in a highly dynamic way. We needed new pristine environments every time we run a test. To give you an idea of the level of testing that we're doing, for every single check-in by a developer every day, I don't care how small it is, even just comments, we're running 8,000 to 10,000 tests. It takes about an hour or so to complete. We're spinning up 8,000 VMs every single day to run those tests. So it matters. I/O matters, getting it right matters, redundancy matters, ease to provision matters, and when you're running this many hosts, 150 plus hosts, it matters that it doesn't cost billions and billions of dollars. So what we really needed was we needed a way to have better deployment time. We needed ways to automate the deployment of our physical servers. We needed ways to reduce the number of cables because there's a huge number of cables, you'll see. And we needed, nobody wants to do things for twice as much money. So it also had to be cheaper, right? So one of the things that we do is we actually pre-configure the server profiles that Cam was talking about. He mentioned it as configure your server profile and then get your box and attach it. We actually do the opposite. We go buy our server from Dell or whoever we're buying from. We like Dell a lot, so we continue to buy from Dell. We buy it from Dell. It takes, maybe a week, 2 weeks to arrive. During that week, 2 weeks, we create all of our server profiles ahead of time because all the Macs and all the WWNs for all the storage and switches they're just virtual. They're nothing more than numbers in memory. We pre-configure them. So we can pre-configure DHCP, we can pre-configure all of our zoning and masking, and we know that it's working. We know that it's ready to go the minute that server arrives on the dock. The minute that server arrives on the dock, all we need to do, plug in a cable, associate the GUI ID for the InfiniBand card that's on the server to the server profile, and everything's done. So really what we're doing, all we're doing once this box arrives, racking it in a rack, connecting 4 InfiniBand cables back up to the directors, turning on the server, and walking away. It's 1 day to rack stack, 1 day to install, 1 day to maybe do some patching or something like that. So automation. So with the thousands and thousands of servers that Salesforce has, there's no way that you do the the clicky through the GUI thing. It just doesn't scale like that. So what was really important to us was a way to script this, a way to make this automated that I don't have to touch it every single time. So what we do is there's a scripting language that Cam didn't have a slide for, but it's really awesome. If you can write scripts in pretty much anything, if you can write in PowerCLI, if you can write in Windows Batch, if you can write in, especially if you can write in Bash, if you can write in Perl, you can write in this language. Simple for loops, that kind of thing. And all we really do is we run for loops to create virtual NICs, virtual HBAs in these server profiles, again, long before they've ever arrived. So I mentioned cable reduction. And why do I really care about cable reduction? Because when I first saw Seago, I was like, really? Do I care about that much? Is that a big deal? It is a big deal. Because when you've got 98 cables coming out of the back of a 16-host chassis, that's 98 cables, one of which is going to break. It's just going to happen. It's going to be incorrectly plugged in or something along those lines. So we had 32 fibers, 64 Ethernets, 2 managements coming out of the back of every single one of these things. Afterwards, we have 4 InfiniBands and 2 management, and that's it. The amount of time it takes to connect 98 cables is it's about a week to get it right. The time it takes to connect 4 cables is 15, 20, 30 minutes on a hard day with a beer. So cost reduction. For us, the server cost, comparing a server with 2 InfiniBand cards versus a server with 2 fiber channel cards, it's about the same. It's about a wash. So where do we save all this money if it's just really a wash in server costs? We saved it because we started moving our aggregation to the Seago director. If you think about when you do fiber channel zoning or something along those lines, you're probably not dedicating 1 port to 1 server. You're doing some level of fan-in ratio, whether that's 2 to 1, 4 to 1, 8 to 16 to 1, whatever it is. So if you're doing that fan-in ratio, it doesn't really matter where you move that aggregation point to, as long as it stays the same. So we moved our aggregation point to the Seago directors, and rather than using 1,200 ports on our SAN with big expensive Cisco switches and all that jazz, we went from 1,200 ports, I think, to 12, something along those lines. Didn't change performance. We actually got better performance. But we saved $1 million, and we're going to keep saving $1 million, and it just gets better after we do it some more, right? So when I deployed this, my boss said, "How much are you going to save?" Because that's really all he cares about, right? So the short version is 78% reduction in deployment time, 2 weeks to 3 days. By automating all the zoning and masking and not trying to collect those values manually, you eliminate a lot of mistakes. We get that great cable reduction. We save $1 million. Who doesn't like saving $1 million? I thought I had pictures in here, but
I didn't copy them in.
Oops,
I was updating.
I was going to show you a
late.
picture of what it really looks like, but nonetheless, that's how it worked. It worked out really well. So thanks.
Any questions for me or Matt? All All right. Well, thanks for coming. Stop by our booth, see our toys.